In practice exercise 4.21 perfect numbers, a perfect number is a positive integer that is the sum of all proper factors. So we have factors including 1, but not the number itself. The first two perfect numbers are going to be 6 and 28, and we are given an example of this right here. We have 1 plus 2 plus 3, that gives us 6. And then we have 1 plus 2 plus 4 plus 7 plus 14, and that gives us 28. We need to write a static method called perfect numbers, so we can have public static. I don't think we're returning anything, so we will have it as void. We are going to have our name here. We are not taking any parameters, so we're just going to leave that blank. And then we have our bracket right here, and that is the header for our function. Inside of here, there are a lot of things that we actually need to do. The first is realize that we are going to get some number, whether it be 6, 28, or 500. And what we're going to need to do, it can be any number, by the way, this can be any infinite number. What we need to do is we need to see how many perfect numbers are in there until we reach this. So this looks like a job for a for loop. Also, we are taking a parameter. That's my bad. We are taking this number as a parameter. So we'll just call it max, int max. So inside of our for loop, we could say it starts at 0, or we could say it starts at 6, since we know 6 is the first perfect number. For efficiency, we're going to do for ints, and we're going to do a is equal to 6, and then we're going to run this as long as a is less than our max, and then we're going to have a plus plus. And so this is the header for our for loop. Now, we are going to need a queue, because the way we print this out is first in, first last. So if we go through this, we find that 6 is a perfect number, we're going to store it. We're going to find that 28 is a perfect number, and then we are going to store it. And then same thing with 496. Or instead of storing it, we'll just print it, but we need to print it in this order. And that's perfect for a queue. So we're going to make a new instance of a queue. It's going to be queue of type integer, and the arrows mean type. We'll just call it number, and we're going to set it equal to a new. We can't set it equal to like a new queue. What we need to do is set it equal to some kind of list, because that's where it's stored in. And simply we will say a linked list. And then it's of type integer. And then we can have our parameters here, and then end this line. So what this is going to do is every time this for loop runs, this is going to make a new instance of this. And it's going to store the numbers in here again, so we can look at the next thing, which would be, in this case, 7. So now we need to check all of the numbers inside of our perfect number, which is 6. 6 is what we're starting with, so that's why I'm saying 6, but we would do this for every single thing. So checking for all of this, we need to use a for loop, and we're going to run our for loop inside of here. As long as our, we'll use b because we're just using arbitrary numbers and we can't reuse a. We're going to run this as long as b is less than our a, because our a is going to be our kind of max for the perfect number that we're looking at currently. Also, b should start at 1, not 0, but we'll get into that in a second. So we're going to want to increment through this, so we're going to have b++, and that is our for loop header. So what we need to do is, by perfect number standards, we need to have the proper factors. Proper factors means that we have some value, so our a value, this is what we're looking at. We can divide it by the for loop values that we're going to increment through. And if it gives us a 0, it's going to be a proper factor. If it gives us a 0 as the remainder, sorry. So if it gives us a 0 as the remainder, it's going to be a proper factor, because we can factor that. So inside of here, what we're going to do is we're going to say if our a modulus our b is equal to 0, meaning again that there is no remainder. We're going to be inside of here, and we're going to do number dot add, because we want to add this into our queue. We're going to add the b value because it is a proper factor. Now b should start at 1, not 0, because we can't divide by 0, so it's going to start at 1 and go through. We can also clearly see that in the example it starts at 1 here and 1 here. So that's going to be the end for that if statement, and that's going to be the end for this for loop right here. Remember again that this is adding in all the proper factors, so we can just write adding in all proper factors, and then this is starting by checking numbers starting from 1, running until our current A, which is like the max value right here for the perfect number. So right, perfect number. And that's kind of labeling everything. And every time we run through this for loop again, we recreate this and we are adding values back into it for the next perfect number. So when we're done with 6, we're going to go into 28. So that is it for that. Now what we need to do is worry about the sum, because this isn't all that we need to do. What we've done so far is we've added all of the actual values into this queue right here. Now we need to check and see if it's the same thing as our current A value. If it is, if the sum of these values, which are the proper factors, the sum of all the proper factors are the same as our value here, then we know that we have a perfect number. So that's what our for loop is going to be here. We're going to say for loop to sum all the proper factors. So this is kind of like a step 2. Right here, we're adding everything in to our queue, and now we're going to be actually adding everything together. And to add everything together, since we have a list, we can use a for each loop. We're going to do for some arbitrary int b. We'll do our colon right here, and we're going to run this for the entire number queue. Inside this for loop, all we're going to have is a sum, which we need to create out here. So we're going to say int sum, and we're just going to initialize it to 0. Every time we run through this, we're going to want to add into our sum. So we're going to do sum plus equals b, because we are adding into sum whatever value we have right here, which is kind of like the index of the elements in this queue. So that's it for that for loop. Now we need to check if the sum is the same as our current A value. And remember, if it is, it's going to be a perfect number. So we're going to be inside of here. We're going to say if, and we're going to do if our A, which is this value, is equal to our sum. We are going to be inside of here, and we're going to do a system.out.print. I forgot a system.out.print earlier, but I'll go back to that in a second. So system.out.print, and we want to print our perfect numbers. And if these are the same, that means that our A right here is a perfect number. So we are just going to have a space and then our A value. Then we can end this line, end this if statement. Before we end the function though, I'm going to go back, and we actually need this part right here. So we need perfect numbers up to, and then we have this right here. So what we can do is print this out before our for loop, because we only want it to execute once. System.out.print, we only want .print and not print line, because it's going to be all in the same line. So we have perfect numbers up to space, and then we're going to append to this our max value, and then we're going to append to this a colon. So we can close this up and end this line, and then end this function. We can click submit, and I need to, well, this bracket ends this for loop, so we can add another one to end the function. We click submit from here, and it's going to run the test. We passed 4 out of 5, but not all of them. And that's because that this needs to run as long as A is less than or equal to our max. So I just put less than, but it should be less than or equal to, because we need to check all the values. And I just stopped it before it even checked the last one, which is why, I mean, sometimes it would work, right? But if it would go up to the very last thing, like for this value, the max value that's inputted is the only perfect value, it wouldn't work. It worked for these, but that's because the max value like this is not the same as the last perfect value. That's why it broke for here. That's why it needs to run as long as it's less than or equal to our max. So we can try submitting it again with our entire code corrected, and we pass 5 out of 5 tests. So that's how we go about doing practice exercise 4.21, which is perfect numbers.